Hey everyone, my name is Lavanya Samantha and I'm going to talk to you about epistasis today, specifically one kind, which is the double recessive epistasis. So let's get started. Okay, so before we get started, I'm going to quickly define epistasis, which is the expression of alleles at one location affects the expression of alleles at another location. What this is basically saying that if you had two alleles, if one of them is fully not expressed, then the other one may not be fully expressed, or the other one could be fully expressed. It depends on what kind of epistasis it is. So when we talk about double recessive epistasis, you will see more as to what I'm talking about. We're going to observe the effects of double recessive epistasis on these two crosses. With both crosses, you can see that under double recessive epistasis, if the genotype does not have both big A and big B alleles, then it does not lead to the final product. So everything else gets combined into one number, as the other genotypes do not contain both big A and big B, so they don't lead to the final product. We're going to see in more details why. So to explain both dihybrid crosses and the effect of double recessive epistasis on them, we're going to use bread dough and baking soda to do so. So bread dough is going to be our A allele, and then baking soda is going to be our B allele. So in both cases, if I have both A and B, then we get our final product, which is bread right here. As you see in the grocery stores, the fluffy bread, it has thickness and the little fluff that we see at grocery stores. And if you don't have dough, which is if you don't have your A allele, which is little a, big B blank, then you only have baking soda, which your final product would be just this. I mean, there wouldn't be no final product. You wouldn't get to your final product, which is bread. So it's just back to square one, nothing, emptiness, no bread, which is our starting point. And then if you just have dough, no baking soda, which means you don't have B allele, you only have A allele, which is A blank, little b, this is what it's going to look like, which is also not bread. So again, we're back to the starting point, which is no bread. And then if you don't have dough or baking soda, which is little a, little b, you also have no final product, because you don't have bread, which is our final product. So you're back to square one, which is no product. So basically, as you can see, is that you need both alleles to be present in the dominance, aka you need both big A dash and big B dash in order to have a final product, which is this. In terms of both crosses, with the first cross, we can see that our ratio was 9:7, which means you would have 9 of these products, which is this, and you would have 7 of our original product, which in this case was no bread. And then with the second dihybrid cross, we saw the ratio was 8:8 for double recessive epistasis, because anything that didn't have dough or baking soda would just not lead to bread. So you just combine them into one number. So that's why it was 8:8. So you'd have 8 of these breads, and the other 8 is just no product or no bread. That is double recessive epistasis.